Hello everyone, welcome to the fourth part of the chapter Sources of Energy. This video would be dealing about nuclear or atomic energy. Now what it is, it's an energy which is released during a nuclear reaction, and this energy is mainly in the form of heat. Now there are two types of nuclear or atomic energy, that is your nuclear fission and fusion. Let's discuss them also one by one in detail. Okay, first of all, what's a nuclear fission? It's a process in which the heavy nucleus splits up into the smaller nuclei when bombarded with a low energy neutrons. So the equation is uranium plus neutron. When it fuses, it gives barium plus krypton plus neutrons. And there is a tremendous amount of energy produced. So the energy which is produced is used for generating electricity at nuclear power plants. An important point to be noted is the energy that is produced by the fission reaction is due to the conversion of mass into energy. The equation of these, that is nuclear fission and fusion, comes in the exam, so please do learn it very carefully. Next we have nuclear fusion. It's a process in which the two nuclei of light elements, they combine to form the heavy nucleus. So it is just opposite of nuclear fission. But the condition for nuclear fusion is millions of degrees of temperature and pascals of pressure needed. Its equation is also there, like two deuterium atoms, that is your light atoms, they fuse and they give only one helium atom, that is your heavy atom, and with neutron with a tremendous amount of energy. Now hydrogen bomb is also there, which consists of a heavy isotopes of hydrogen, that is deuterium 2H and tritium 3H along with the lithium. So this was about nuclear fusion. Okay, now let's move further. Nuclear atom bomb. It's a highly destructive nuclear bomb which is based upon the reactions of uranium-235 or plutonium-239. There is an Einstein mass relation which says that the mass and energy are equivalent, that is equal to mc to raised to the power 2. Energy units for expressing the nuclear energy is, there is 1 electron volt, EV, is the amount of energy which is required by an electron when accelerated through a potential difference of 1 volt. Okay, so this was about it. So 1 electrovolt, is equals to 1.602 into 10 to the power minus 19 joules. Now let's move further. First of all, let's discuss the construction of a nuclear power plant. What happens is there is a uranium fuel, okay, which is carried in the steel pressure vessel V of the reactor R. Then the enriched uranium-235 rods marked A called fuel elements. They are inserted in a core which is made up of graphite blocks inside the reactor, and the graphite is called your moderator, and its function is to slow down speed of neutrons to make them fit for causing the fission. So in between the uranium rods are inserted boron rods B, and they are the controller rods. Why? Because they observe excess neutrons and they prevent the fission reaction from going out of control. Okay, then there is a reactor. It is enclosed in a concrete chamber M having thick cell walls to absorb the nuclear radiation. Then liquid sodium is used as coolant to transfer the heat produced in the reactor by fission to heat exchanger or boiler for converting water into steam. Now let's talk about its working. Nuclear atom bomb. It's a highly destructive nuclear bomb which is based upon the reactions of uranium-235 or plutonium-239. 9. There is the Einstein mass relation which says that the mass and energy are equivalent, that is equal to mc to raised to the power 2. Energy units for expressing the nuclear energy is, there is 1 electron volt eV is the amount of energy which is required by an electron when accelerated through a potential difference of 1 volt. Okay, so this was about it. So 1 electrovolt, yeah, is equals to 1.602 into 10 to the power minus 19 joules. Now let's move further. Now let's see the advantages and disadvantages of nuclear energy. You can see it from here. We'll move further. Last, we have steps to reduce energy consumption. So you can switch off the lights. You can use CFL, that is compact fluorescent lamps. Good quality stoves can be used, cookers, pressure cookers, then use of bicycles we can do for the short distances and all these. So this was all about this video. Thank you so much.